Hello kids, welcome to Mammoth Online. So here we have a wonderful question from previous year, and the question is, domain of a function f of x is given, that is tan inverse of some function, quadratic and under root, plus there is a secant inverse of a function which is also quadratic. So when they ask domain, it means the x value should satisfy both tan inverse function and secant inverse function. Only then it will be valid. So let's see how to do this. So let's begin our function f of x. Now here, let's talk about tan inverse of this function. To understand this, we have to know a little bit about tan inverse function. So let's see how tan inverse function looks like. So as you can see, this is how our tan inverse function looks like, where this is the graph of tan inverse function. And you notice something, that the domain for this function is actually the entire number system. That is, this entire x-axis is actually possible for tan inverse function, and the range is from minus pi by 2 to plus pi by 2, open interval. So if this is the case, that means this entire expression under root of x square plus x minus 2 can belong to real number, because the domain of tan inverse is real number. So this entire thing can be actually real numbers. So if that is the case, it means root of x square plus x minus 2 can belong to real numbers. Nobody is stopping it. So this entire thing is only valid if x square plus x minus 2 is valid. That means it should be positive inside the square root. So x square plus x minus 2 should be positive or equal to 0 inside the square root. Only then this will be valid. So let's see how to do that. So if x square plus x minus 2 should be greater than or equal to 0, we can use wavy curve. We can actually factorize this thing, that is x square plus x can be written as 2x minus x minus 2 greater than or equal to 0. So if you simplify, this will be x plus 2 times x minus 1 greater than or equal to 0. Now you can see the number line where these are becoming 0, and you can see it is becoming 0 at minus 2 and it is becoming 0 at 1. So according to wavy curve, every value beyond 1 will be giving you positive results. Between minus 2 and 1 it will be giving negative results, and lesser than minus 2 it will be giving other positive results. So this is the positive region, this is the positive region, that is why we call it wavy curve. So therefore we get minus infinity to minus 2 closed, because it is equal to also, and 1 to infinity, and this will be our solution number 1. Now that we have solved for tan inverse part, let's talk about secant inverse part also. Now we have secant inverse of x square minus 5x plus 3. Now to understand this, we need to understand a little bit about secant inverse function. Now look at that, secant function is actually something like this, where this is our pi by 2, because that is where it is undefined. So we need to take those part which is invertible. So if you take that, you will see that this part can be inverted. Similarly, here it is pi and this part can be inverted. So when we invert only in this range, that is from 0 to pi, where pi by 2 is excluded, when you invert this, then our actual range for secant inverse, because here secant domain is actually 0 closed to pi minus pi by 2. This is our domain for secant x function. And the range, as you can see, is from 1 to infinity here, and here minus infinity to minus 1. So this is our domain, and our range is minus infinity to minus 1 closed union 1 to infinity. This is the secant x function. When you invert this, what will happen is we get a secant inverse graph where our range will become the domain and domain will become the range. So let's see that. Now as you can see here, this is the graph of secant inverse x, and as you can see here, the range of secant inverse x is from 0 to pi, leaving the pi by 2 part, but the domain is actually from minus infinity to minus 1, that is this part, and also 1 to infinity. There is nothing that exists in this between region, minus 1 to 1, there is nothing existing there. So we have to talk about domain where it is minus infinity to minus 1 and 1 to infinity, which means whatever is inside, like this part, should always lie from 1 to infinity, or it should be from minus infinity to minus 1. So now let's solve this particular problem. So we can write x square minus 5x plus 3 should be greater than or equal to 1. or x square minus 5x plus 3 should be less than or equal to minus 1. So these are the two conditions. So let's solve for this one. Now, if it is x square minus 5x plus 3 greater than or equal to 1, then this can be simplified as x square minus 5x plus 2 greater than or equal to 0, because 1 goes this way. And if you solve for the quadratic roots for this one, the two roots alpha and beta can be found as minus of minus 5, which will be plus 5, plus or minus under root b square is 25, minus 4ac, 4 times 2, 8, and then we have divided by 2 here, so that is 5 plus or minus under root of 17 by 2. So we can write this as x minus of the smallest root, that is 5 minus root 17 by 2 times x minus 5 plus root 17 by 2 greater than or equal to 0. Now, in the wavy curve part, we can easily solve for this one. The first root is 5 minus root 17 by 2. The second root is 5 plus root 17 by 2. And it is positive here, negative here, positive here. So when you draw a wavy curve, this is the positive region. This is where we want. So one of the solution, let's say S2 is actually from minus infinity to 5 minus root 17 by 2 to 5 plus root 17 by 2 to plus infinity. So let's write that. Now similarly, we can find out that x square minus 5x plus 3 should be also less than or equal to minus 1. So in this case, it will be x square minus 5x plus 4 less than or equal to 0. We can simplify this as x minus 1 times x minus 4 should be less than or equal to 0. So when you simplify this, the smallest root is 1 and the bigger one is 4. So it is plus over here, negative and plus using wavy curve method. Since they are asking for less than 0, that means this is the region they are interested in, that is. So we understand that secant inverse x square minus 5x plus 3, if it is there, x square minus 5x plus 3 is greater than 1 for S2, that is minus infinity to 5 minus root 17 by 2 and 5 plus root 17 by 2 to infinity. And it is less than minus 1 at 1 comma 4, closed interval. So now if you plot these things for secant inverse function, you will see that this is minus infinity and this is 5 minus root 17 by 2. Somewhere here we have 1, then we have 4, and somewhere here we have 5 plus root 17 by 2, and then we have infinity. So S2 is from minus infinity to 5 minus root 17 by 2 to 5 plus root 17 by 2 to infinity, and 1 by 4 is here in between. Now, as you know, for the solution of secant inverse, either it can be S2, that is it can be greater than 1, which is this region, or it has to be, if it is less than 1, then it has to be less than minus 1. It has to go to less than minus 1, that is this region. So our combined solution will be simply S2 union S3. So when you find S2 union S3, we get a simple solution, that is all this region will be valid for us. This region and this region is all valid. So we find out that our S1 is simply minus infinity to minus 2 closed union 1 to infinity, and our S4, which is a combined solution of S2 and S3, let's say, our S4 is simply union of S2 and S3, and we got that as minus infinity to 5 minus root 17 by 2 closed union 1 to 4 union 5 plus root 17 by 2 to infinity. Now, our solution for this entire function will be when we have S1 and intersection S4. When both are satisfied, that is our grand solution S. So let's figure out how to do that. So if you think about S1, let's say the pink region, that is minus infinity to minus 2, and then we have 1 to infinity. Now, if you talk about the other region, let's say the blue region, that is solution 4, we will see that solution 4 exists from minus infinity till 5 minus root 17 by 2, and then 1 to 4 it exists, and then 5 plus root 17 till infinity it exists. So wherever there is intersection, that is this region, as you can see, there is an intersection, this region there is an intersection, and this region there is an intersection. Wherever there is an intersection, that will be our S region. So if you label all of that, that is minus infinity till minus 2 closed union, then we have closed 1 to 4 union, then we have 5 plus root 17 by 2 till infinity. So this is our grand solution S. Now if you look at the options, that is the D option that is satisfying this. So this is how you can solve for some complicated domain related questions from functions. So kids, this is how you solve this particular problem. I'll see you in the next video with some more interesting problems like this one. Thank you.